this is 1.5b, and we're going to be using our exponent laws that we learned last class, and we're going to be looking at even more complex equations here. So here it wants us to simplify, write all powers with positive exponents. So that means that we have to get rid of any negative exponents. So the first thing that we're going to do, make this a bit bigger, is we're going to get rid of any brackets. So any exponent that's outside of our brackets gets multiplied inside the brackets, and that's our first step. So for our first bracket, we have a 2, so this 2 is going to go on the 4, the x, and the y. So here we get 4 squared. We have x to the minus 1 times 2, so we get x to the minus 2. Then we have y to the 3 times 2 becomes y to the 6. This x in between just means multiply, so these brackets are multiplying each other. So now we're going to deal with this bracket, and it's going to get multiplied by 3, everything inside. So the 3, the x, and the y. And we just write it next to it. We just keep going. So 3 to the 3, x to the minus 6, y to the minus 12. And then that's going to all be over this bottom bracket, and everything inside this bottom bracket is going to be multiplied by negative 1. So we get 4 to the negative 1, x to the negative 3, y to the negative 3. So that's our first step. Next, we need to look for common bases and combine them together. So here we have a 4 and a 4, so we can combine those. X squared. Now remember, when something's on the bottom, we're going to subtract. So we end up with minus 1, which you can write as 2 plus 1. Our next base that we're going to look for is x. So we're going to find all the x's, and we're going to combine them together. So here we have x to the minus 2 plus negative 6 minus negative 3. And if we simplify that, we get negative 2 minus 6 plus 3. Next base is, let's see here, use purple. Next we have y. So here we have y to the 6 plus negative 12 minus negative 3. So if we simplify that, it becomes 6 minus 12 plus 3. And then finally, we can't forget this 3 to the 3, even though it has nothing to combine it with. We'll just write it over here as 3 to the 3. So now we actually need to add all these up. So when we do that, we get 4 to the 3, x to the minus 5, y to the negative 3, 3 to the 3. Now we need to move anything that has a negative exponent. It needs to change where it is. So if it's on the top, it goes to the bottom. If it was on the bottom, it would go to the top. So these guys are on the top. We're going to move them down. So we get 4 to the 3. I'm going to put a dot to show it's times. 3 to the 3 is equal to x to the 5, y to the 3. Then we need to see, these are on the same level, so we can't simplify them at all in terms of crossing anything out, but we can expand them. So 4 to the 3 becomes 64, 3 to the 3 becomes 27, x to the 5, y to the 3, and then we multiply 64 and 27 together, get 1,728, x to the 5, y to the 3, and this is the final answer for this one. So we have to make sure that anytime you have a number with an exponent when you're doing these questions, that you don't leave it like that. It needs to be expanded. Okay, let's look at another example. So this time we have a negative exponent, or an exponent in general, for an entire bracket. Okay, so you can do this two ways. You can flip this and then multiply everything by the exponent, or you can multiply everything by, so it would change it to be positive 3, or you can multiply everything by negative 3. And then the same thing here, everything inside, both top and bottom, gets a 2 on it. So let's just multiply everything by negative 3 to show you what that would be like. So 9 to the negative 3, x to the negative 3, y to the negative. Now this time we already have a 3 here, so we have to multiply 3 and negative 3, so we get 9. And on the bottom, we have 8 to the negative 3, x. Here we have negative 3 times negative 3, so 2 negatives. So that's going to be 9. And then y to the, here we have negative 3 and a 2, so that's going to be negative 6. Then we'll expand our bar, and we're going to put what we get from here, we're just going to continue on the same bar. So now these are just one big problem together. So 3 to the 2, x to the negative 4, y to the 4, and then on the bottom, 3 to the 2, x to the negative 2, y to the 4. All right, so we have one big long problem. Now we need to combine any like terms together. So what do we have? A 9, we're going to look, there's no other 9s. Next thing we have is a x, so we're going to find all the x's. And we're going to combine those x's together. So I'll write the 9 to the negative 3. I'll write it here. And I'll write my x's next to me. So we have negative 3 minus 4. Now I'm just going to go straight for changing the signs to what they would be. Minus 9 plus 2. The reason why this is plus is because it would be minus minus changed to a plus. Next we have y, so we're going to combine all the y's. So here we have y to the minus 9 plus 4 plus 6 minus 4. Okay, next we have this. Here we have a 3 to the 2. Here we have a 3 to the 2. One on top, one on the bottom. So these guys actually cancel out, so we can get rid of them. And then all that we have left on the bottom right now is an 8 to the negative 3. Right here. Okay, so we can simplify our x's and y's, and we can also move these two. So we can rewrite this as 8 to the 3, and then when we do our x's, here we have negative 3 minus 4 minus 9 plus 2. Whoops. So we get negative 14. And then over here, we have negative 9 plus 4 plus 6 minus 4. So negative 9 plus 4 plus 6 minus 4. So we get negative 3. And then we moved our 9 to the bottom. So 9 to the negative 3. So just to show that this went down, this one went up. Okay. Oops, and it's no longer negative. It's just 3. 9 to the 3. All right, so then we want to get rid of these negatives. So that means that these two are going to move to the bottom, and we can also expand our 8 to the 3 and our 9 to the 3. So 8 to the 3 becomes 12. 9 to the 3 becomes 7, 29. And then this and this both move to the bottom. So this goes to the bottom, this goes to the bottom. So we get x to the 14, y to the 3 for the answer for this question. All right, we're going to look at one more. So now we have a very large bracket with an exponent on the outside and then smaller brackets inside. So the first thing is that this exponent goes to the outside of the brackets, not to everything inside the brackets. So this exponent goes to the 2, the negative 2, and the negative 1. And if there was no, let's say there was stuff on the bottom here with no exponent, you would put it in brackets, put an exponent of 1, and then the 3 would multiply the exponent of 1. So our first step here, we get 3 to the negative 1, x to the negative 2, y to the 3, and then we have 2 and 3 gives us 6. we get 4x to the negative 1, y to the negative 4, and then we have minus 6. And on the bottom, we have 6x to the 5, y to the negative 2, and then minus 3. Now we need to take these smaller brackets and multiply the exponent inside each of these brackets. So this 6 goes on these 3 guys, this negative 6 goes on these 3, this negative 3 goes on these 3. When we do that, we get 3 to the negative 6, x to the negative 12, y to the negative 18, 4 to the negative 6, x to the 6, y to the 24, all over, 6 to the negative 3, x to the negative 15, y to the 6. So now we need to look for like terms. So first we'll look for 3. There's no other 3. We'll move on to our x, x, x. So I'll write 3 to the negative 6, x to the negative 12, plus 6. Then this would be minus minus, so it becomes a plus. Our next is our y's. So we have y to the negative 18 plus 24 minus 6. And we have nothing to pair this 4 to the minus 6, so I'll just write it over here. And then there's nothing to pair the 6 with, so I'll write on the bottom 6 to the minus 3. Okay, so now we can simplify. So we get 3 to the minus 6, x to the 9, y to the, what have 36? Is it negative 18? Oops, I made a mistake here. This y is a positive 18, not a negative 18. There we go. So that's a positive 18. Sorry about that. All right, so then this y is to the 36. And then we have 4 to the minus 6 over 6 to the minus 3. So now we need to move things that have a negative exponent. They change where they are. So this is going to come down, and this is going to go up. So we get 6 to the 3, x to the 9, y to the 36 over 3 to the 6 times 4 to the 6. Now this is the first time in these examples that we've had something that is going to be able to simplify. Okay, so there's multiple ways you can simplify. You can multiply these out and then try and find common numbers. But I think the easiest way is to factor the numbers and then cancel. All right, so what do I mean by factor the numbers? So here, 6, we know that 6 is 2 times 3. So this, a 6 splits into 2 times 3, okay? If we have 6 to the 3, we need to keep the same exponents on the basis. So 2 to the 3 times 3 to the 3 is the same as 6 to the 3, okay? And we're going to do the same thing for 4. So 4 is 2 times 2. 2 times 2 equals 4. And if we have an exponent of 6 on the 4, we need to keep the same exponents on our 2's. So now if I write this out, I get 2 to the 3 times 3 to the 3. So instead of our 6, we're going to write 2 to the 3 and 3 to the 3. And then we have x to the 9, y to the 36. So our letters didn't change at all. And we have a 3 to the 6. And our 4 became 2 to the 6 and 2 to the 6. So now we have similar bases because we have 2's that match up and we have 3's that match up. So now we can simplify. So here we have 3 to the 3 and 3 to the 6. So we can cross this guy out. And remember, when we're moving across top and bottom like this, we subtract. So this guy becomes 3 to the 3. 6 minus 3 is 3. And then over here, we're going to cross this one out, and one of these is going to become 6 minus 3 is a 3. Then we can combine these two together, so we have 2 to the 6 and 2 to the 3. We can add those. 6 and 3 becomes 2 to the 9. So let's look at what this would be. On the top, we only have letters left, x to the 9 and y to the 36. On the bottom left over, we have 3 to the 3. 3 to the power of 3 is 27. And then we have left over 2 to the 9, and 2 to the 9 is 512. We have to expand fully. So 27 times 512 is 13824. So our final answer for this question is right here. So now you can go into your homework and try page 45, number 6.